questions. And before I get going, I just want to take a moment to thank God for blessing us all. I lost a dear friend last weekend from the coronavirus, Joel Sandell. He's on my video team member. He was appointed at the code making panel 5. He was one of my proudest students. Took all our courses and videos and DVDs and books, and passionate. And the pinnacle of his career at that point was that he was on the Mike Holt video team. So we just lift up the Sandell family in New York City. I'm going to be doing a special event in New York City whenever it becomes safe, benefit seminar, and hopefully we can make a difference if we can help that family. All right, ready to go? Now, for those on Instagram, just be aware I cannot read any of your questions. You can't make any comments that I'm going to be able to read. Traditionally, I say go to MikeHolt.com/live, but we're having a technical problem right now on MikeHolt.com/live. You can watch us live on Facebook, and you can watch us live on YouTube. All right, here we go. First thing is, my microphone is not on. We didn't have that checked. So, got to turn on my microphone. Okay. Again, if you're on Instagram, I cannot see any of your questions. Send them to Mike at MikeHolt.com, and I will be able to cover them at another time. I already have the questions submitted prior, and I can do this. And I apologize, and there's no way on Instagram for me to be able to see your questions without having to watch the whole Instagram feed. So send your questions to Mike at MikeHolt.com. All right, here we go. Termination of conductors. Now, this one is going to be very, very interesting. Some people are going to like it. Some people are like, are you ready for this? Here's a question that came up to me. And I did an Instagram live a few months ago about the termination of aluminum conductors. We're going to really expand this. Here's the question. Mike, is aluminum or copper-clad aluminum wire required to be terminated differently than copper? Is an antioxidant grease required? Mike, a lot of work to get involved here before I answer that question. First thing is, let's be aware that aluminum wire back in the 60s, and this is from Wikipedia, the use of older solid aluminum wiring in residential construction resulted in failure of connections at electrical devices. It has been implicated in house fires, according to the U.S. Consumer Product Safety Commission. And in some areas, it may be difficult to obtain homeowners insurance for a house with older aluminum wire. So if you have older aluminum branch circuit wiring, there's a good chance your insurance company is not going to give you any kind of coverage because of the problem with the aluminum wire at that time. Here's what it says. There's several possible reasons why these connections failed. The two main reasons were improper installations, poor workmanship, and the differences in the coefficient of expansion between aluminum wire used in the 1960s and the 1970s and the terminations. I think that's a bunch of total crap. Electricians have been putting in receptacles and switches back in the 1960s for like about probably 60 or 70 years. And they were using copper wires, and they were using switches and receptacles that were specifically listed to be used with copper wire. Now they come up with aluminum wire in the 60s and 70s. And the reason they came up with aluminum wire is because copper became very, very expensive as a commodity. Why did copper get expensive in the 60s and 70s? The Vietnam War. I mean, when you make bullets, you need brass. When you need brass, you need copper. And if you were around in the 60s and the 70s, you would have known that the cost of copper wire was astronomical. So the result in the 60s and the 70s, aluminum wire came out. But the problem with the receptacles and the switches were never identified and listed for that, and the screws that they were using was steel. And what this said right here was about there was a difference in the temperature coefficient and expansion, meaning that when aluminum wire got hot, it expanded and it contracted with the temperature, but steel terminations or terminals and screws, they expanded and contracted at a different. Plus there's a dissimilar metals between aluminum going on to steel. You can have aluminum oxide on there. So there was all kinds of problems. This was not an electrician screwing up, okay? So I have a little problem with that. And it says, two main reasons, electricians screwing up and the differences in the coefficient of expansion between aluminum wire used in the 60s and 70s and the terminations, particularly when the termination was a steel screw on electrical devices. I got you there. Okay, this wasn't what I was planning on covering, but if you go to a house that has aluminum wire, you can buy a switch and a receptacle that's marked, I think it's COAL, which is copper aluminum, which means you can then take the aluminum wire that's already there and directly connect it to the device. In addition to that, they make wire connectors. I believe Ideal, I'm sure maybe other wire connectors make it also, which is a wire nut or whatever you want to call it. They make wire connectors specifically identified for the intermixing of both copper and aluminum conductors. So if you're going to go into a house that has aluminum wire and you want to replace the devices, then you're going to not be able to take the aluminum wire on your standard receptacles. Now, the COAL devices, switches and receptacles, I don't know how easy they are to access, and I'm sure because of the supply demand, their cost is going to be, I don't know, 2 times more than it would cost regular device. So, or you know what, just get Ideal wire connectors or whoever else makes them, and then pigtail the aluminum over to the copper, terminated on copper terminals. Now, today's receptacles would be for copper and aluminum, but the other ones for aluminum direct connection is a different story. Okay, for that aluminum wire, you gotta realize that aluminum wire in the 60s and 70s is not the aluminum wire that you're using today. So if you put today's aluminum wire, then there's no incompatibility with the expansion coefficient. So you're good. It's when you have the old aluminum wire, you cannot put today's receptacles, or of course, those receptacles. You have to make a transition. So, all right, so that's brain circuit wiring. We just kind of talk about that. Now, when it comes to feeders, again, in the 60s and 70s, because of the cost of copper going up so high, the industry migrated to an aluminum conductor, but it was utility grade aluminum wire. It's the power line aluminum wire. They just went ahead and put insulation on that, and they sold it to electricians. Electricians put it into installations, and then we had problems with that aluminum wire because it had an oxidation. It's called copper oxide. And that's the kind of stuff that we cover in our electrical fundamentals. You have to understand physics before you can understand the code completely. So because the aluminum wire was a new aluminum wire for feeders, as you can see in this illustration here, then the termination required that you take a brush, and there was instructions in there. You take a brush and you first of all, see, as soon as you cut the insulation off and you expose the aluminum wire to oxygen, it is said that it immediately oxidized. It created aluminum oxide. Well, aluminum oxide, we covered this in electrical fundamentals in our theory class. It's where you have the valence electrons going to be filled in by other electrons, and the more electrons in the valence electrons, the more of an insulator it becomes. So now you take the insulation off, it exposes to the air, oxygen hits the aluminum, it creates aluminum oxide, and then you put it in a terminal and you tighten it down, and those terminals were not designed for that type of aluminum wire, and all the torquing that was required, that was not designed for that aluminum wire. So they said, take the aluminum wire and brush it off. And then put an antioxidant grease. Well, Nolox, Penetrox, a lot of people call different things. I'll tell you a little story. I thought, man, that must be some great stuff. And I had a problem with the battery. So what I did was I thought, you know what? I'm going to put this, I think we used Penetrox at the time, or Nolox, what it is. I put it on the battery terminals, 12-volt DC battery, and then I put the clamps on there. Do you know I couldn't even start the bat? I couldn't even start the truck because apparently it's not really that conductive. So that's just side note. This is not like it's a conductive device. This is designed to protect the aluminum conductor from oxidizing so it could maintain conductivity. Well, we had all kinds. If you go into any kind of old house that had aluminum feeders, you probably see the insulation melted back 3-6 inches, and the thing looks like steel. It gets so hot it looks like steel. So it was a real problem. So those who are in the industry, man, we were pissed off about aluminum wire. We had aluminum wire for the receptacles and for the switches and for the feeders, and we just hated it. So understand some history. This all started because of what? The Vietnam War. because we didn't have copper. It was too expensive. All right, so you got that little story there. But look, this text right here is talking about this. It says, look, aluminum building wire for modern construction, it's probably like, okay, since 1980, 90, 100, 10, like 40 years, okay, maybe 30 years, somewhere between 30 and 40 years, they came up with a different aluminum wire that actually was designed for building wiring. And it's manufactured as an alloy, aluminum alloy 8000, AA 8000. That's what we buy for building wire. Listen, that doesn't have an aluminum oxide problem. You just take the insulation off and you don't freak out. You don't take a brush and brush it off. You don't put antioxidant grease on there and put it in the terminals. But you know what? You got these dinosaurs that are still around. And that's what they did 40 years ago. And they hate aluminum wire. And they're telling you, and matter of fact, it would be in instructions, it'll be in catalogs. You're going to see this talking about putting some kind of antioxidant grease on your conductors. Just realize, no. The manufacturers of aluminum wire do not require this on there. The terminals do not require this. UL does not require this. And the National Code does not require it. It's just some people out there that are dinosaurs that heard something, or they told somebody, or some dinosaur told you, and you've been telling somebody else, and you're just flat out wrong. That was more than 40 years ago that we had this problem. We don't have a problem with aluminum wire. So just kind of get over that. All right, let's read this on. Aluminum building wiring for modern construction is manufactured with aluminum alloy 8000, AA 8000, series aluminum alloy, sometimes referred to as new technology aluminum wire. Are you kidding me? This is 40 years now, guys. Let's get over this. As specified by the industry standards such as the National Code, the use of larger gauge stranded aluminum wire, larger than A gauge, is fairly common in much of North America for modern building construction. So when you're talking about building wiring, it would be larger than 8 gauge, 6 gauge and larger. That's probably about right. And, so we just give you information. Let's go a little further. Okay, so now, today, okay, we're not talking about 1960 and 1970 crap. We're talking about AA 8000. We're talking about copper conductors. And I'll talk about another conductor in a minute. Terminals. 110.14 talks about terminals. And it says this. Terminals are suitable only for aluminum, must be marked AL. Terminals suitable for both copper and aluminum must be marked CUAL or ALCU. Today, we don't pay attention to terminals. You get a wire, you put it on the terminal, you tighten it up, you make sure you comply with 110.14D, you torque it properly. Now that's what I'm talking about. 110.14D. Go back and get your code book, read it over and over again, get a torquing tool. The dinosaurs are worried about putting the no-locks on there, and they're not using a torquing tool. The new guys, the millennials and the Generation Zs and all you guys in there that are like trying to do it the right way, and these older guys are giving you a bunch of crap. You just take the wire, strip it, stick it in the luck, and get a torquing tool, and you did it right, and they're doing it wrong still today. Just saying. So look here. If it's marked CUAL, that means it's rated for 75 degrees C terminals. If AL, aluminum, that's copper only, 75 degrees C, aluminum only, that means that you can use 90 degrees C wire on the terminals, but you just can't run current at the 90 degrees C column of table 31016 using the 2020 code for this program. And if it's AL7CO, 75 degrees C column, if it's CUAL, CU9AL, okay. Just because a terminal is marked 9, which means it's suitable for 90 degrees C, does not mean that you can go to table 31016 and size the conductor to the 90 degrees C column. You cannot do that. Because, see, the terminals that are rated 90 degrees C would be installed within equipment. When it's installed within equipment, like a fusible disconnect, in a panel board or a switchboard or switchgear, motor control center, when terminals are installed in equipment, 110.14C1 takes over. And it says for circuits rated 100 amperes or smaller, then you're going to size the wire in table 31016 based upon the 75 degrees C, the 60 degrees C. And if it's over 100 amperes, you're going to go to table 31016 and size the wire to the 75 degrees C, and you will never use a 90 degrees C for terminals that's going to be with an equipment, and the equipment will be marked. Okay, now let's get to reality. All equipment is rated 75 degrees C. So forget the 60 degrees C column, because 110.14C 1A, probably 3, maybe it's probably 3, says that if you get a conductor that is listed for other than 60 degrees C, then you can size those conductors for other, and they will be listed for 75 degrees C. So reality, what do you do, guys? Except Romex. Okay, we'll talk separate story about Romex. Don't do Romex at 75. You go, table 310.16, and you size the wire to the 75 degrees C column. But if the terminal is marked 90 degrees C, does not change the rating of the size of the conductor terminal in equipment. That's a 110.14C2. I covered that in my Understanding NEC, and I covered my exam prep book, and I explained all this stuff. So I don't want to get too far in the woods here. Okay, so now we got aluminum wire or copper wire. So here's an example of a lug. Even though it's rated copper aluminum, I'm sure you can see that, 9 degrees C, you cannot size the conductors to 9 degrees C. Why do they make those lugs? Well, because there is an actual time that you size at 9 degrees C, but that's not within the program here. All right. I got this picture. Oh, that makes the dinosaur happy. Oh my gosh. You got some grease in there, you got it on your hair, you got it on your face, you got it in your shirt, you got it all over the place in there. And I don't really care about that. It's not required by the code, it's not required by the listing of the product, it's not required by the manufacturer, it's not required by the terminal manufacturer, it's not required by the aluminum wire manufacturer. I bet you that terminal's not torqued though. Now, I've heard this about the antioxidant, what people have done with it. Some people put it on the aluminum wire and they stick it in a lug and they tighten it up. Okay, whatever. It's not required. Is that going to hurt anything? No, it's not going to hurt anything. It's fine. Some people put it on the outside of the terminal. I heard one guy say, well, Mike, I don't put it on the aluminum wire because I don't even need it on. I put it on the outside of the terminal wire, on the outside of the terminal so it doesn't corrode. Who cares if the outside of the terminal corrodes? Because that means if it is, you got bigger problems. But no. Another person says, well, I actually take the threads out of the lug and I put it right on the threads. Oh my gosh, no, don't do that. Because 110.14D says you're supposed to torque it. When they designed the torquing terminations in there, nobody put a grease on the threads. Do you know what it might take now to get that thing torqued properly because of the tension? Who knows what the heck you're going to do to those threads? No. Some guys actually put that on copper wire because if it was good on aluminum, dang man, that got to be better on copper. No. So you see no locks, you see Penetrox in your truck, pitch it. Get rid of it. Don't do anything with it. Okay. Now, there's a new conductor on the market out here. And you guys are going to be really happy about this or you're going to be really pissed. It's called copper clad aluminum. It's really not a copper clad aluminum. It's really an aluminum where molecularly the copper is bonded to the actual aluminum. So it's actually a single conductor. It isn't like you have a ground rod. You get a ground rod. Give me a copper ground rod. That's not a copper ground rod. That's a steel ground rod. It has what? It has a copper coating on that. Copper-clad aluminum wire does not have a copper coating on it. The aluminum is molecularly bonded to the copper and it makes a single strand. Now, I don't know what size strands they use, and I don't know if I was a wire guy, I probably would make sure that I would size single strands in a way that I could then combine the single strands, I could then get different gauge size wire. In other words, so now, look right here. This is Romex. I hate Romex. I love Romex. So here's a Romex, and this is copper-clad aluminum, which is really not a copper-clad. It's a conductor. It's not copper conductor. It's not aluminum conductor. Okay, it is a separate conductor type, which is copper-clad. It's actually a copper-bonded aluminum conductor. So I guess I don't know what color white is. You guys have to tell me what color white is. White is traditionally for like a 15 amp circuit, I think. See, here's why I'm confused. Well, see, white is not 14 gauge. See, if you thought it was white is 14 gauge, well then that's where you're screwing up. Because white, if it was copper, it would be what size wire? 14 gauge. And what size breaker? 15 amps. Where would you probably run that wire? Probably mostly in a house, okay? So you have a 15 amp circuit, a 15 amp breaker, and you got a white jacket. Got it. You're thinking it's 14. No, it's 15 amps. And then you go over to yellow. You might be thinking, well, yellow is for 20 amps. Yellow is for 20 amps. Well, yeah, no. Thinking yellow is going to be, see, 12 gauge wire. No, it's not 12 gauge wire. Yellow is for a 20 amp circuit. So you're going to have to start making a little adjustment here because we have a new wire method. You see this white cable right here? That white cable could be used on a what? A 15 amp circuit. Do you know what size conductor copper clad aluminum wire is for a 15 amp circuit? You have to go to table 31016. Now there's a problem in the code. See, the code says it thinks there's copper wire and it thinks there's aluminum wire. Then the 2020 code said, well, wait a minute now, guys. We need to add copper clad. So the 2020 code added copper clad in a lot of spots, not enough spots. And if you go to table 31016, you're not going to find the ampacity or copper clad conductor on that table. You're going to see copper. You're going to see aluminum, but not copper clad. So the practice is, right now, because we have nothing else we can do, as a matter of fact, I was talking to a gentleman from the American Bimetal Association, Peter Gracer. And he's helping me and educating me in all what's going on in there. He has been appointed Code Panel 6. Get your code book out. Look what the articles are, Code Panel 6. Ready for this? 310, conductors. 311, medium voltage conductors. 320, armor cable. 322, probably something like flat conductor cable or something like that. 324, I don't know, 326, 328, 330, MC cable. 332, don't know what it is. 334 Romex, 336, 34 Romex, 330. Tray cable. 337, don't know. 338 is going to be service entrance conductors. 340 to UF cable. 382, I don't know. 394, I'm not sure what it is. 396, I don't know. 398, 399, I don't know. 400, that's going to be flexible cords. 402, that's going to be fixture wires. So, you know, Peter Gracer, who's now representing the American Bimetal Association, has a lot of work for him. And you know what? Peter, I know you're watching this video. Everybody hates you. The copper guys hate you because you're selling a product that's cheaper than copper. But yet, guess what? Because it's a bonded bimetal, that means that it's a copper surface, which means you can terminate that conductor at any terminal that's rated for copper only. So before terminal said copper only, you had to use copper wire. Now you can use what? Copper clad aluminum. The aluminum guys are going to hate you because before it was just we were just fighting the copper guys, and the aluminum guys were fighting the copper. Now all of a sudden you come in the middle and say, hey guys, I'm here at the party. I just want you to know that you don't have to use aluminum and you don't have to use copper because I have some features here that's going to actually make those people, those guys that hate aluminum, perfect. Don't use aluminum, use what? Copper clad aluminum, because it's a copper surface. Now looking at the copper clad graphic here. So this is a 15 amp cable, and it's going to be 12 gauge wire. This is a 20 amp cable, and it's going to be 10 gauge wire. Orange, I guess, is going to be a 30 amp cable, and that's going to be, I guess, I'm assuming it's got to be 8 gauge wire. And I don't know, black, maybe that's a 50 amp circuit. We got two black ones here. And it goes, guess what? Man, can you believe that? You can buy I don't know what size the maximum they sell, but this is probably 500,000 copper clad aluminum. Now, the ampacities of copper clad aluminum will be the exact same thing as an aluminum. Clearly, there's a copper coating on the outside. For those guys that have a problem with aluminum, well, maybe copper clad aluminum solves your problem. Okay, what's my position on copper clad aluminum? I'll give you a little story. 1975, I installed copper clad aluminum, Romex. I didn't have a problem. I never heard of a problem. Copper clad aluminum was I won't say it was a big player, but it was a significant player for anybody that was doing any kind of residential wiring. If you're doing large condos, you're doing housing projects, back in the 70s, is when 1970, let's see, that would have been 1973 when I wired that 5-story building where the code limited to 3. Another story, we're not going to talk about that story. But it wasn't me, I was just a foreman on the job. No problem with copper clad aluminum then. But it went away. And I asked Peter, I'm like, what the heck's going on here? Why? And I met Peter at the North Carolina Institute, and he had a booth there. And I have a tendency to be a little arrogant when I meet these sales guys, because usually they're stupid. They just say a bunch of dumb things, and I just don't have patience for that. And I saw him, and I saw this wires, and I'm like, yeah, copper clad aluminum. I did that back in 1975. What's that, 45 years now or something like that? And 1973, actually, so it's over 45 years. What's the big deal? So he's educating me on what's going on. And you know what happened? I said, well, what happened? Why did I do it in 1973? And now all of a sudden you're at a trade show and you're talking about how wonderful and great copper clad is. There had to be something wrong with copper clad aluminum that you guys kind of like took off for a while. And you know what he said? Mike, copper clad aluminum is only cost effective when the cost of copper goes over $2 a pound. When it's below $2 a pound, it's not cost effective. Guess what happened in the 60s? They needed a lot of bullets. They needed a lot of brass. So guess what the federal government did? They took a lot of copper. So what do you think cost of copper went up? It shot up. And then guess what happened? I'm sure a lot of people were not happy about the Vietnam War ending, because all of a sudden all these copper mines were producing all this copper to create all this brass for all these bullets. Well, that's gone. Copper then takes a dive. But guess what happened? When copper went over $2 a pound, then copper was so expensive and you really couldn't get it, and it's so heavy that they went with copper clad aluminum. After the Vietnam War, everybody's standing around a lot of copper. Hey man, we'll give this stuff away. Well, then guess what happens to when it gets below $2, it's not cost effective for copper clad aluminum. Now look at the history here. Now, about somewhere between 1999, somewhere in there, maybe 2005 or somewhere in there, all of a sudden copper took off. Why was copper take off? Well, because guess what? All the copper mines and all the copper people are like, listen, we got a problem here. They created a cartel. They fixed the price of copper. So around 2005, it goes up. But that doesn't mean that if you're a wire manufacturer that you're going to be in the selling it. While it goes up, it stays up. A little dip downside here, and guess what happens? The cartel is not about to allow copper go below $2 a pound. So now the American Bimetal Association is like, okay guys, let's get out there, let's get your salesmen out there, let's go tell everybody about this wire method. And then people are like, well, it's not in the code, you can't use it. That is a little bit of a problem, because it wasn't in the code, but it was added to the code in the 2020 code. And I'm sure Peter will be on the panel 6, will be giving information so that they can clarify any areas where there's a problem. All right, so that takes care of that. So that's the deal with copper, aluminum, copper-clad aluminum. Hopefully it answers that. And you know, while we're talking about terminals, why don't we just finish up 110.14a? Terminals are listed for one conductor, only one conductor. Now in the 1970s, I'm not going to say that that's my job looking at that graphic. But if it was my job in 1970, mixing that aluminum wire, twisting it on the outside there, and then putting the copper conductor, getting a 4/0 lug, and then getting a fender washer, and getting a drywall screw sticking it in there, I'd have been pretty proud of that job. I'm going to tell you that. I did a really nice job. We did not know that the equipment grounding conductor, which the 2020 code made it very clear, is part of the effective ground fault current path. And that's how you clear a fault. We did not know anything about torquing. I'm sure it was all there. We didn't have the education you guys have today. Look, you got a free video right here. You're learning stuff that you probably would never hear in your lifetime if I didn't say it. We didn't know about mixing copper and aluminum and the whole thing. We just got the stuff that was mechanically out of the way and stuck it in there and goes at it. So we've come a long way, and you guys, the younger guys, are going to be much better than we are. One wire goes under a terminal. That's it. Now, they do actually make some strange terminals, and maybe somebody can get a photo and they can send it to Mike at MikeHolt.com. I've only seen it maybe once or twice, where if you looked at it, and I can't remember, so I might be completely wrong. It seemed like you could put 3 conductors in one opening, but yet I can't remember if there was 3 different screws or if it was 2 conductors in a single screw. So manufacturers can make fittings however they want to make it with the instructions. So if there's a fitting like a split bolt bug, well, that's only suitable for 2 wires. But there are apparently split bolt bugs that you can put in 3. I haven't seen that. So 1 wire per terminal. Oh, what about pre-testing? Oh man, the dinosaurs, man, do they go nuts if you make a splice and you don't twist that wire together before you put it onto that wire nut. I can't tell you what percentage of the splices I did that I actually twisted the wires together. I really don't know what percentage. I don't think it was 50%. I'm thinking maybe closer to 20% or 10%, or maybe just, I don't know, how did the planets line up that day? Why did I twist those? I don't know. Maybe I felt something. I have no clue. But the way wire connectors are listed, the way that they are tested, they take the conductors, whatever the number and the size that's identified for that fitting. Now, listen, make sure you know how many can fit in that fitting, and make sure you know what size wire can fit in the fitting. Now, that's a big deal. Not that you twist them all together, but you get the right amount in there. How many times you twist it together, you're trying to get the wire nut on there, and it keeps slipping and slipping and slipping and slipping. So then you put what, a little longer and a little shorter so they can try to, come on. If you want to twist them together because you're experienced, and you okay. Some guys twist them together, put the wire connectors, and then they put electrical tape on top of that. Whatever. Twisting, not required. All right. So that was a lot more time than I thought I was going to spend simply on terminations. But you know, if you really think about this, there's nothing more important than terminations, because if you don't terminate properly, that's where we have fires. Sizing conductors, terminating properly is where we have fires. So let's go on to the next one. Termination of the grounding electric conductor to water pipe electrode. Brian, do we have any questions that come up at all anywhere? Right now I don't have anything on the feed. Is MikeHolt.com/live working? First night. Okay, well, good. All right. Let's go. Termination of grounding electric conductor water pipe. Oh, I hate water pipe electrodes. I really hate this whole thing. Okay, here we go. Ready for this? Is the grounding electric conductor, which is the wire that you run, let's say from the service disconnect or from the service meter, we talked about that in the previous video, to the metal underground water pipe, required to be located, be connected within 5 feet of the metal water pipe entry into the building. You know, I went into 250-68C1, and if you get your code book out and you look at that, I think that's what they're saying. So we're going to make a public input to clarify that, and that is that it should be real clear. The termination of the grounding electric conductor to a metal underground water pipe electrode should be within 5 feet of its point of entry into the building. It kind of says that, but it also says this. It says that that water pipe, which is above the ground. See, your grounding electrode water pipe is the pipe that's under the ground. When it comes above the ground, that's not a grounding electrode anymore. But you can use the water pipe as a conductor to connect to the electrode. Well, yeah, okay, whatever. And that pipe can go up to 5 feet at point of entry, and you can use that as a conductor. So if you're going to have more than just a water pipe, see, the water pipe electrode is required to be supplemented by an additional electrode. So there aren't many places that today, being a brand new building, they're putting in a metal water pipe to the building that's 10 feet or more outside. But if it is, well, then that's going to be an electrode. But you have to supplement it with another electrode. So let's say a brand new installation, 10 feet of water pipe, what would you supplement it with? Well, we talked about that in the previous video, and that is that you have to use a concrete encased electrode if it's going to be there. And we talked about the concrete encased electrode is probably 1/2 inch rebar, 20 feet of total assembled parts together, and the footer foundation could be a conductor, but more than likely it's rebar. And before they poured the concrete, it was there. You better get to that concrete encased electrode, and you have to get to the water pipe. And it's kind of like a lot of different ways on how you can make that connection. And maybe there's other electrodes on the premises. And what they're saying is this: that water pipe up to 5 feet of point of entry can be used as a conductor connection. So what you could do is you could run a wire from your service meter or disconnect, it doesn't really matter, to the water pipe. Okay, so that's your grounding electric conductor to one electrode, which is using that as an extension. Then if you have a concrete encased electrode, you can take your concrete encased electrode and terminate it to the water pipe and use the water pipe for the purposes of interconnecting electrodes, like bonding them together, but only up to 5 feet. So that's what 250-68C1 is saying. It's kind of like leaning the conversation about using it as an interconnection, but in reality it also applies that that's the greatest amount of distance inside of the building that you could terminate that location. So let's review a graphic here. If you have 10 feet or more underground, then that is your electrode. Everything above ground is not the electrode, but up to 5 feet of point of entry, you can use that for the purposes of terminating the grounding electroconductor 2 or for interconnecting other electrodes. So you can see right here, this ground rod is connected right to this water pipe. So what can happen is we could run the grounding electroconductor with a clamp to the water pipe and then take the ground rod electrode bonding conductor and connect it to the water pipe and use the water pipe for the purposes of interconnecting electrodes. Okay? Talking about the water pipe being supplemental, a supplemental grounding electrode for the underground metal water pipe must terminate to one of the following. Okay? One, you can terminate the supplemental electrode to the grounding electroconductor. So I can just go right here to the wire that's going over there. I could do that. The service neutral conductor, I can take it over here in the meter can. It happens to be in the service disconnect, but it could have been the meter can. Service neutral conductor. You can take it to this metal service raceway. You can actually take it right to a raceway. Don't see that very often. Don't make any sense, but you could. And you can take it to the service disconnect enclosure. Well, you can take it right to the enclosure. Well, probably taking the enclosure would be to a lug that's in that service disconnect enclosure. Okay? So the supplemental electrode is going to be as if you lost the water pipe electrode, you still have an electrode. So the supplemental electrode is not permitted to be terminated directly to the water pipe electrode. All right? This is the rule about the 5 feet of point of interior. Oh, you know what? Looks like I got a code violation here. Because the water pipe is an electrode, I have to supplement the water pipe with a supplemental electrode, and I have to take a look at it. I don't think 53D test says I can take it to the water pipe. So one of these, I'm going to take the rebar. Mike Corbett, you're watching this. Get me a grounding electroconductor over, the rebar, Mike Corbett, have it come over here and terminate to the grounding electroconductor because the supplemental electrode can connect to the grounding electroconductor. Okay, so fix that. So the rebar goes to the grounding electroconductor and all other electrodes can be bonded to the water pipe and using the water pipe to interconnect electrodes up to a point of 5 feet from the point of entry. And of course, this is all outside, but if this was inside, that's your distance. Oh, this is a great one. Okay, we got a question coming up.
All right, Mike, we got a couple questions.
All right, Brian, I'm ready for your question.
Got a couple questions. We're headed back to copper-clad aluminum real quick. First question, copper-clad aluminum. Is it okay for equipment grounding conductor? How about for the grounding electrode conductor?
Oh, the question is, can you use a copper-clad aluminum conductor for the grounding electrode conductor? That's why Peter is on code making panel 6. Peter, you better pay attention to this, and you're going to have to learn. And I talked to you about getting my library and buying my library and study all over the place because they hate you when you get into the code panel. You better learn about conductor sizing and Article 250 in particular. So let's talk about, here's the problem. I could go to 250.66. Oh, yes, it does. Look at that. It's already in there. 250.66 says how to size the grounding electroconductor, and it gives you a size for copper, if you look at your code book, and it gives you a size for aluminum or copper-clad aluminum. So I knew you could use copper. I knew you could use aluminum. I didn't know if this table included copper-clad aluminum. The answer is, yep, it does. So the answer is, yes, you can use a copper-clad aluminum. Absolutely. But you have to size it to what? To the column that says aluminum, copper-clad aluminum, which is not copper. Any other question? Okay, good question. All right, so now, the anti-short bushing for MC cable. The dinosaurs, man. They're out there. You young guys, you read a code book, you get information, you get all excited, you go to the job site, you try to tell somebody in there, and they try to make you feel like a total complete idiot. Listen, I understand that most guys, most people in the trade, and I don't know about ladies, we're getting, at the last, my seminars that I'm doing now, engineering, because I do a lot of engineering seminars, it's getting to be about 8 or 10% of the ladies in my engineering seminars, 8 or 10% are women, and that is cool. Electricians, apprenticeship programs, a lot more ladies are in apprenticeship programs, and I love it. These guys, these ladies, I'm sure, are just smoking all the guys. Just education, they're studying, they're doing everything, and then of course they're getting all kinds of crap. Ladies, you get a bunch of crap from guys on the job site, don't take it personal. They give everybody a bunch of crap. Okay, maybe actually you a little less than they would another guy. So you have the dinosaurs, and as you're learning, don't worry about these guys. They're going to be gone one day. So let's talk about anti-shear bushings for MC cable. Mike, is the red plastic bushing supplied with the MC cable required to be installed? I was told by an experienced coworker that it's not required by either the product standard or the code. Of course not, it's not required. Here we go. So Mike, what's the deal about anti-shear bushings? Well, armor cable, they make fittings for armor cable. And armor cable, I'm sure, came out before BX, came out before MC cable. So they had whatever kind of fittings they had, they required a plastic bushing. It doesn't have to be red, but I think it's only red. And what you do is you take this 18 gauge aluminum bonding strip for armor cable and you cut it off. Some guys are like, well, you know, you put the anti-shear bushing in there and then you kind of wrap it around inside there, or you bring it out and you make it, just cut the thing off. And if you want it, see, when you wrap that 18 gauge around there and then you put that in the fitting, that fitting was never designed to have some 18 gauge wire wrapped all around the end of the fitting. It was designed that you cut that off right there. Because see, that 18 gauge is a bonding jumper, and it bonds this steel convolution right to that one. And that's all it does. And then it goes and the other one bonds that one to that. So what that does is it makes the sheath of armor cable to be listed as an equipment grounding conductor, and that's 251.18, I want to say 9, maybe, somewhere in there. So now, that's the purpose of the wire. Cut it off, take the anti-shear bushing, stick it in there, and here's what it said. This is 320.40, here's what it tells you. An insulating anti-shear bushing must be installed in all type AC cable terminations. The termination fitting must permit the visual inspection of the anti-shear bushing once the cable has been installed. So you have to use a fitting, which is 110.15. You have to use a fitting specifically listed for armor cable, so that you can look in there and you can see the anti-shear bushing. So that is required for armor cable. MC cable requires a totally different fitting, and it does not require any kind of visualization to see if the anti-shear bushing is there. If you look at an MC cable fitting, if you're actually getting MC cable fittings when you're running MC cable, another story. But if you get them, you'll notice when you look inside there that there's like a stopper, a little ring stopper in there, and the conductors kind of go within the ring stopper. And so therefore, there is no requirement for an anti-shear bushing for MC cable because it is a different fitting, it is a different type of construction. So the answer is no. Well, I don't like, but how do I prove that? Okay, fine. You want proof? This has been around since 2002, but the dinosaurs, I don't care about that kind of crap, you gotta do this. I'm like, oh my gosh. Does people actually stop learning and think they actually believe that they know everything there is ever to learn? So when you see somebody who's not willing to hear you out and to learn new things, realize that person actually already learned everything there is in life, and they can't possibly learn anything else. Seriously. Okay, here we go. Let's go to the bulletin. The use of anti-shear bushings for terminated type MC cable. I'm going to read the text. I don't normally do this, but I want to read this one. Oh, you know what? I wonder if I have the text here. There we go. So the text is there, but I kind of stuck it in here. There has been much confusion within the insulation and inspection communities regarding the use of anti-shear bushings and terminations type MC cable. The confusion stems from the fact that some MC cable manufacturers include anti-sharp bushings with the cable. Mike, you see the anti-sharp bushing came with the cable? You think they're not required? Give me a break, Mike. So you say, well, if they're not required, Mike, then why are the manufacturers including them in there? You know why? Because people think they have to be put in there. And so they yell and scream at the manufacturers, well, you didn't include the anti-short bushings to the MC cable. So like, okay, we'll try to be nice guys, but we'll include some anti-short bushing, because they're not code experts. They include the anti-short bushings with the MC cable, and then people actually think you have to do it. So a guy who actually reads the code, reads NEMA bulletins, knows what's going on, is feeling pretty good, goes out there, doesn't put anti-short bushings, take those suckers, pitches them away, because you realize something. The fitting for MC cable was never designed to be using anti-short bushing. So probably if you put an anti-short bushing, I would say you're violating the code, because 110.3b says you have to install it according to the instructions. The instructions don't include anti-short bushings in MC cable. Let's go back to the text. The confusion stems from the fact that some MC cable manufacturers include anti-short bushings with their cable. They're trying to be nice guys and they're just shooting themselves in the foot. The inclusion of anti-short bushings with coils or reels of MC cable is based on historical practice. Again, dinosaur. Fittings used with type MC cable are required to be listed per 330.40. What was the rule of armor cable? Oh, look at that. 320.40 was the anti-short bushing rule. 330.40 is similar rule, except it's talking about the fittings. The design of these fittings are required to be provided with a smooth, rounded end stop, so that the metal sheath of the cable will not pass through and the wires will not be damaged in passing over the ends of the stop. It's a special fitting. That's why you don't have anti-short bushings. What you don't want to use is use an MC cable, put anti-short bushings on a fitting that's not listed for MC cable. You're just screwing everything up. Next one. These listed MC fittings, you have to use listed MC fittings for MC cable, do not require an additional anti-short bushing. Anti-short bushings that may be supplied by the MC cable are an option used by the installer. However, they are not required. Let me go back here. You get that video and snag that sucker. But let me give you information. That's a NEMA Bulletin number 90, August 14, 2002, reaffirmed December 11th, 2014. But you know what? There's people out there like, I don't care. I don't care about that crap. And Mike Holt, that guy is just, he's just a troublemaker. Probably true. Okay, looks like we're going to get maybe one or two more questions in here. Height of a receptacle in a garage. I remember this when I was working in the trade. Mike, I'm wiring a storage garage because the garage will be most likely store gasoline. Is there a minimum height requirements on the placement of the receptacle? It's kind of like, you got gasoline, you're going to store gasoline, and like a garage at your house. Okay. First of all, 511.3a talks about parking garages. If you're just going to park a vehicle in a space, then that garage used for parking or storage shall be meant to be unclassified. So you park a car or a vehicle in a space and you're not using gasoline to be taking let's say a gas tank out and taking an engine out, you're just parking the car. That's not classified. Now, there's a reason why I'm saying this. It's in my understanding UNC 2 when we get into hazard classified locations. So if you don't understand what it is, you really need to get a bit more knowledge. I think you need to. That way you can be educated. So here's just a typical garage. Oh, I didn't show the picture here. I got the graphic, and unfortunately I pasted. So what I did was I had my graphic designer, Mike Corbett. Mike, give me a graphic down here low. I apologize I didn't use it. Because I don't want anybody thinking that there is a height location. The code requires that you have one receptacle in the garage. And I'd have to look at the language that I'm not really, I'm going to rephrase that. You need one receptacle per vehicle bay. So if you can park 2 cars in this space, then you need a receptacle outlet per vehicle I can't remember what word to use them. So if you have a 2-car garage, you need 2 receptacle outlets. That means they're 2 separate boxes, and you could have a single receptacle or a duplex receptacle. You can't use one receptacle with a duplex receptacle because a receptacle outlet is the box with the receptacle. So if you need a receptacle outlet per parking space, well, then you need 2 separate boxes. I know there has to be a height limitation on that, and at the instant, that would be 250. No, that would be 21052, probably E is what I'm guessing. I don't think it's H. I think it's E. And I'm sure, actually I know that 210.52, right in the beginning of 210.52, says that receptacles that are above 5.5 feet do not meet the requirements of the required receptacle. So if I'm in a garage, I need a receptacle outlet, which is a box and a receptacle, for each vehicle bay. It can't be above 5.5 feet, and there's no minimum height that it has to be. Put it on the floor if you want. It doesn't really matter. The fact that you might be putting a 5-gallon container or a 1-gallon container of gasoline in there does not change that, because it's not a classified location. But let's talk about a commercial garage where you actually are going to be servicing vehicles. You see them all over the place there. Well, you have to go to table 511.3, and there's a table 511.3C, and it all depends on, like, well, what are you going to be doing in that garage there? I mean, are you just going to be changing brakes, and you're not pulling out motors? Are you just putting oil in there? So in some cases, that space would not be considered a classified location. And if it's not considered a classified location, well, then there would be no minimum height that you would put in a commercial garage. But in some cases, that height, depending upon what work is going to be, it's a minor garage, major garage, and then within the work that's going to be taken in there, it would be considered a classified location, more than like class 1, class 2, because it's above the pit area. Then, well, the rule is anytime you're putting a receptacle in a location that's classified, let's read the rule here. Receptacles, attachment plug should be the. Oh, that's wrong. I got you the wrong code wrong. Receptacles shall be part of premise wiring. Attachment plugs shall be. All right, I don't have the right code rule. And I apologize, and I'm not going to look at it right now. And somebody will be able to post it on there. Here's the deal. Receptacles installed in a classified location. So if it's a Class 1 Division 2, it's going to be identified and listed as suitable as a Class 1 Division 2. If you're going to be in a Class 1 Division 1, like in a pit area, then that receptacle would have to be listed and identified for a Class 1 Division 1. And I apologize, I got the wrong code section there. All right, while we're here in commercial garages, we kind of jumped over commercial garages. Let's go to 210.8B8. And I'm probably going to repeat this one another time in the future when I cover GFCIs. GFCI protection required for all receptacles located in garages, accessory buildings, and service bays in similar areas. So now, interestingly enough, if you park a vehicle where there's a door, what are you going to call that door, okay? If you park a vehicle inside a space and you have this door that comes up, which would be a garage door, then the area around the vehicle is a parking garage or a storage garage. And 210.8AB8 says that those receptacles within that location is going to have to be GFCI protected. If we go over, if we get over to 511, I can't remember what rule there, and you're going to be into commercial garages. And by the way, all these receptacles in the garage, parking and storage garages, would have to be GFCI. It doesn't matter the ampere rating of those receptacles. So in a dwelling unit, all the receptacles have to be GFCI protected. Doesn't matter what the ampere rating is or what the voltage rating is. Okay, it's just going to have to be GFCI protected. I think the amperes doesn't matter either. Yeah. Commercial, it's just a little slightly different thing. There's some values in it. Maybe residential. I'm going to take a look at that. That one I'm 10. That 8A. on garages, 2108A. Yeah, it doesn't matter the ampere. Okay, I was right. All right. And in commercial garages, there is a requirement all receptacles in a commercial garage are going to have to be GFCI protected as well. All right. I'm not going to go any further, but I got some questions coming in. Oh, Brian, I'm ready for your questions.
All right, Mike, we got a question that says, going back to AC and MC cable, can you use AC connectors with MC cable? And to go along with that, you can address it at the same time. What about the connectors that are built into the box?
300.15 says wire method is conduit tubing, AC cable, MC cable, MI cable, non-metallic sheet cable, or other cables. A box or conduit body shall be installed at each point. Well, that's not one. Wiring methods, equipment. Oh, I skipped 300.15. Went to the third paragraph. It says fittings and connectors shall be used only with the specific wiring method for which they are designed and listed. So, if you're running armor cable, AC cable, it better be marked. You better look at the box. It says AC cable. If you're running MC cable, it better be marked on the box or somewhere telling you that's MC cable. If you're running Romex, it better be marked saying this is for non-metallic sheet cable. If you're running Flex, it better be marked. Now, there's a possibility that some manufacturers, particularly Arlington manufacturers, these guys are pretty amazing. They always come up with cool products. I'm sure somebody's come up with a fitting that is suitable for a lot of wire methods. You might have seen like some large fittings for like rigid metal conduit, 2.5 inch and larger. It'll be marked EMT, IMC, RMC. So what about if you get a box that has the fittings in it? If you get a box that has the fittings in it already, then you'd have to find out what kind of, that would be an MC cable. That would be for MC cable. So easy. If you don't know what it is, then just get the box and look at the instructions. It'll tell you whether it's for armor cable, MC cable, NM cable, flex metal conduits. You have to use the fittings that are identified for it. One more question.
Okay, so going back to garages, can you use 2 single receptacles, 1 single receptacle per outlet bay on a GFCI breaker?
All right, I'm going to quickly go to 210.52. E was outlets, so that was wrong. It wasn't E for the garage. It wasn't H. It was G. I wasn't even close. There's a G1, G2, G3, and G1 says this. That's 210.52 G1. In each attached garage with electric power, at least one receptacle outlet, go to Article 100 definition, read what that is, shall be installed for each vehicle bay and not more than 5.5 feet. So it's right there. So you need to have a receptacle outlet, which is a box with an opening with a receptacle. You can put a single receptacle in there, like I said earlier, or a duplex receptacle. But if you have a 2-car garage, you need 2 separate boxes with whatever kind of receptacle you want to put in there. It would be cheaper to put a duplex receptacle, obviously, than to put a single receptacle. Brian, you think that answers the question? All right, guys. Well, God bless. We got another recording coming up tomorrow. And then in May, I'm going to start talking about, let me just press this button here. In May, I'm going to start talking about your career. Are you an apprentice? Hey, Mike, I'm an apprentice. I don't know what to do. I don't know what's going on here. Are you a guy that's been a helper for a long time and you've never been licensed? Let me tell you something, guys. You can't do that. You got to take care of your family. Are you a journeyman? Are you a master electrician? Are you an electrical contractor? Are you an inspector, an engineer, a contractor? So the first week of May is going to be talking about life skills. It's going to be talking about your career. And I'm going to answer your questions to try to help you better direct what do you need to do to take your life to the next level. Because you know what? Money is not everything. But at a personal level myself, I didn't have any money as a kid. I was poor. Go to MikeHolt.com, go to videos, and click on the video, free videos, and click on that video and learn about my story and learn about where I came from and where I'm at today is I have some skills and I have some reasons there. So the first week of May, but I need you to start sending me questions now. Hey Mike, here's my story, here's where I'm at, and then the first week in May, we're going to be talking about your career. We'll finish up the code in April. We've got 3 more weeks, and then we're going to get into personal development.